Millions of Americans are spending $2,000 to $3,000 every year just to heat and cool their homes. And many of those homes are called smart. They have Wi-Fi thermostats, room sensors, app-controlled air conditioners, sealed windows, insulated walls, and the latest HVAC technology. On paper, this looks like progress. The house has more devices, more automation, and more control than any home in history. But now, shift the camera a few miles into rural Pennsylvania. An Amish farmhouse sits quietly in the winter cold. No smart thermostat, no Wi-Fi control panel, no central air conditioner humming outside. Some of these houses were built around principles that go back 200 years. Yet inside, the temperature can stay near 65 degrees Fahrenheit, or about 18 degrees Celsius through the coldest part of winter, with an operating cost of $0. That is not magic. It is not luck. It is thermodynamics and economic math. Heat moves, air rises, stone stores warmth, sunlight changes angle by season. A house can either fight nature with machines or cooperate with it through design. Today, we are going to break down the engineering principles behind these no-electricity homes and answer the most important question: why modern building codes make building a house like this today almost illegal. Amish-style houses maintain their comfort because the structure itself is designed to function harmoniously with thermal energy, sunlight, air, and the ground. The first principle is geometry versus machinery. Many modern homes are built to face the road. The front of the house points toward the street because that is easier for the builder, cleaner for the subdivision, and better for curb appeal. The Amish do not think that way. They do not build the house around the road first. They build it around the sun. The house is oriented toward the south, usually with an error of less than 10 degrees. That matters because the sun changes position by season. In winter, the sun stays low in the sky. Its light can enter deeply through the large south-facing windows and warm the inside of the house. The floor, the walls, and the heavy surfaces absorb that heat during the day. In summer, the sun rises higher. Now the roof overhang naturally blocks the sunlight before it enters the glass. So the same house collects heat in winter and avoids heat in summer. It is heating itself with mathematics. The second principle is thermal mass versus insulation R-value. Modern homes often use fiberglass insulation. Fiberglass is good at insulation because it slows heat transfer through the wall. But fiberglass has almost zero thermal mass. It does not store heat. That means when the furnace turns off, the house can get cold quickly. The Amish secret is different. They use thick stone walls, sometimes 18 inches thick, and a masonry heater. This masonry heater can weigh up to 5,000 pounds, or about 2.2 tons. When two pieces of wood burn for 2 hours at around 1,800 degrees Fahrenheit, the stone absorbs the heat. Then that heavy mass releases the warmth slowly for the next 24 hours. The third principle is fluid dynamics and the geothermal breathing tube. Warm air rises. When warm air escapes through high south-facing windows, it creates a stack effect. That rising air pulls cooler air in from the north side of the house. Some traditional designs also used underground clay pipes, like a small hypocaust system buried 6 to 8 inches below the floor. Cool outside air enters those pipes, moves through the earth, where the temperature stays near 55 degrees Fahrenheit, and then enters the home. This is not an electric air conditioner. It is geothermal cooling powered by the laws of physics. Now the obvious question appears. If these principles work so well, why do modern American homes not use them everywhere? The answer is not that builders forgot physics. The answer is that the housing system chose speed financing and legal compliance over long-term operating cost. The first problem is the price of cheap and fast. To build a masonry heater that weighs about 2.2 tons, you need a massive foundation underneath it. That foundation must carry the load safely for decades. To build stone walls around 18 inches thick, you need skilled manual masons, not general labor, not a fast framing crew. You need people who understand stone, mortar weight, moisture, and time. That means huge labor cost. Modern houses use 2x4 wood framing because it is cheap, repeatable, and easy to mass produce. A crew can frame a house in a few weeks. Materials arrive in standardized sizes. Developers can estimate costs quickly. Banks can finance the project easily. Inspectors know what they are looking at. The whole system is built for speed. So we made a trade. The Amish model gives you cheap operating cost but expensive construction. The modern model gives you cheap construction but expensive operation. You save money when the house is built, then pay the energy companies every month after that. The second problem is building codes and the airtight paradox. Modern homes are wrapped in house wrap, foam, sealed windows, and tight insulation layers to maximize energy scores. That improves efficiency on paper, but it creates a new problem. The house becomes so airtight that natural ventilation is no longer enough. Without mechanical ventilation from HVAC, ERV, or HRV systems, carbon dioxide and moisture from human breathing can build up indoors. That moisture can feed mold if the air is not managed properly. This is why modern codes do not simply trust open windows and natural airflow. The International Residential Code pushes mechanical air exchange for health and safety. The Amish system is brilliant, but it was not designed for the modern blower door test. In today's legal world, a house must not only breathe, it must prove by code exactly how it breathes. So, the lesson is not that you must sell your car, throw away your phone, and move into an Amish community to lower your electric bill. That is not realistic for most people. The real lesson is simpler. You can borrow the physics without copying the entire lifestyle. You can build a modern version of the same idea safely, legally, and without touching dangerous electrical or structural systems. Start with a solar buffer. If the south side of your home receives strong sun, plant deciduous trees there. In summer, the leaves create shade and reduce the heat, hitting your walls and windows. In winter, those leaves fall away, allowing low-angle sunlight to reach the house. It is the same seasonal logic as the Amish roof overhang, but translated into landscaping. A tree becomes a living shade device. Next, use windows with intention. At night, when the outdoor air is cooler, open a low window on the ground floor on the north side, then open a higher window on the second floor on the south side. This creates a natural crossflow. Cooler air enters low. Warmer indoor air escapes high. The house begins to breathe without forcing a machine to push every cubic foot of air. Then add thermal mass where the sun already lands. Instead of covering the entire ground floor with carpet leaf, tile stone, or exposed concrete in the south-facing areas that receive sunlight, during the day those surfaces absorb heat. Later, when the air cools, they release it slowly. You are not trying to turn your house into a museum. You are simply giving it something modern. Homes often lack a place to store comfort. So the practical lesson is simple. You do not need to live like the Amish to learn from the way they build. Their houses are not miracles. They are monuments to a time when people had to cooperate with nature instead of fighting it with electricity-hungry machines. A south-facing wall was not a decoration. It was a solar collector. A stone floor was not just a surface, it was a thermal battery. A high window was not just a view, it was part of a breathing system. Every piece of the house had a job, and that job was to reduce dependence. Modern construction gave us speed. It gave us standardized materials, faster framing, cheaper financing, sealed walls, and predictable inspections. But it also created a strange bargain. We can build homes faster than ever, but many of those homes turn us into permanent customers of energy companies. The house is cheaper to build but more expensive to live in. Now look at the home you live in today. Would you rather pay 30% more for the foundation and structure to build a natural heat-storing system like the Amish used? Or would you rather keep paying $2,400 a year for the convenience of modern air conditioning and heating? Tell me your choice in the comments below. And if the Amish way of managing temperature surprised you, you will not believe what ancient builders once did with water-filled roof systems. Subscribe so you do not miss the next breakdown.